One of the key things, I guess, coming back from that is the technological advancement criteria. So when we talk about that paper itself, the eligibility of work and scope, one of the things that I find is that the CRA really has a bad definition of technological advancement. CRA's definition of technological advancement is the act says you have to have technological advancement, so you write a project that illustrates technological advancement by technological advancement, uncertainty, and systematic investigation by qualified personnel. I'm saying, what? You just use a word to define itself. You can't say to me, show me your technological advancement by showing me your technological advancement. That's a self-fulfilling definition. The answer should be, show me your technological advancement by first describing objectives beyond standard practice, then related uncertainties and systematic investigation by qualified personnel. I'm saying if they took box 240 of the T661, and instead of saying, what technological advancement did you contemplate at the outset of the project? And then providing examples where they actually give you the conclusion as the first thing to really confuse the heck out of you. If they said, describe objectives that go beyond industry standard practice, which is really what they want, then people who fill out these forms would actually provide the information that they're looking for, instead of something that's not what they're looking for. So again, I've made that recommendation for 10 years. I'm sure no one there is going to listen to me, but it's a huge opportunity for guys like ourselves, because no client who reads that is going to put the right stuff in box 240. Until you tell them, forget what they say, tell us what your objectives are and how you define standard practice to show it wasn't readily apparent. And they're going to nail it every single time. So again, CRA is creating a huge opportunity for guys like us to basically say, don't listen to what they say, listen to what they really mean. If you read their circular, they're telling you, you have to benchmark standard practice and provide objectives beyond that. So again, I think the simplification and streamlining is say, this is everything you ever need to do and support. You want to tell us, how did you benchmark standard practice in a technological advancement? My view is technological advancement involves 5 components, not 3. And if any single one's missing, you could lose the entire claim. But if all 5 are there, you have a solid claim. You will win in court every single time. You don't have to submit the CRA vagaries. You can say, look, I want to go talk to the judge, end of story, and by the time you get a Crown attorney in, they're going to realize that their client has a losing situation, and they're going to settle. The weaknesses are as follows. 1, you didn't tell them what you did before you started the work. And everyone does the same thing. You do internet searches, Google searches, articles, patents, whatever. Talk to suppliers, talk to experts. Keep some notes on that, you're golden. If everybody does this, less than 50% of people keep it. I'm not joking. They do, I did 20 Google searches, I had 20, hey, where's the articles? Oh, you wanted me to save those? Yeah, save as. How long did that take? A second. Do it. You spend an hour finding the article. How long is the save as? 3 more seconds, and we got a solid SR&ED claim. So again, put the systems in. They don't give quantifiable objectives. Well, I don't blame them. Read any of the CRA examples. They say you have to have extremely accurate measurements. The courts say you must have extremely accurate measurements and analysis of those measurements. Without such measurement analysis, systematic investigation can't exist. And you read the CRA examples, none of them have measurements and analysis. So you have to ad lib. You have to say, well, it's a good start what they got, but you can't really submit what they're showing. You have to actually do a better job. You have to rise above the bar of the examples they've given. What I would say is, if you can provide at least 3 benchmarks with measurable parameters, cost, performance, pressure, anything. Hey, we're at $100 a unit, we want to go to 98. We're at 1,000 pounds per square inch, we want to go to 1,200. I don't care. Something that can be measured, that's objective, that's verifiable, that's scientific, is really the guiding point here. And as you stack up more and more objectives, they tend to create more uncertainties. Hey, I know with unlimited time and money I can make this table out of plastic, but you're saying $100 a unit. Holy smokes, now I got to start experimenting with different materials, different methods, things to make it work. So again, it's not often one single objective, but when you put all of them in combination, the stack-ups of the objectives create what I call stack-up tolerances or issues that then create the uncertainties. My other big push is saying, what the heck is technological uncertainty? Technological uncertainty to me is very clear. If you have an existing model for something, my flow software says if I'm going to mold this part I should use pressure of this and temperature of that and whatever other 7x times 3y plus 4z is the formula to mold this particular part. Standard practice or the standard formula. So if I can say, well, you know, that's what the world-class modeling software I use recommends, and yet when I go into practice it didn't work. There's something wrong. Either they're missing one or more variables, or the variables that they have aren't correct in my particular situation. The world's leading software, the models that we have do not work for me. But I'll figure out, I'll start doing some tests, and I'll see if maybe they misrepresent the pressure, or maybe I can tweak that existing formula to make it more accurate to my situation. To me, that's clear. There's no clearer example of technological advancement than that. There's industry standard practice. There's the actual variables, the complete understanding of why does it work, and ultimately the conclusion at the end that ties to the variables. So if I write a sentence, I don't know if this is going to work, and it works, there's no technological uncertainty. If I say, I know this is going to work, but I don't know the optimal combination of temperature, pressure, glass fiber content in the mold, and the effects of viscosity on this resin that I'm using all at the same time, that sounds like variables of uncertainty. The clients who can do what I call a DOE, design of experiment model, where they say, here's the most relevant factors, and we're going to test this and see how it affects the other ones, and then this, and then this, and then this, X, Y, Z, W, whatever our components would be, always get the claim. Very few clients, when you ask them, can do this. When I say, what are the variables of uncertainty? Sorry, in certain industries, they have a problem doing it. In other industries like chemicals, they will get it every time because it's, oh, easy. Here's my top 8 variables of uncertainty. Here's how I'm experimenting. It's a slam dunk. That's a solid SR&ED project every time. You couldn't lose on that. All right. So uncertainty to me, what are the top variables? And a crack team may identify 60 or 70 variables, at which point you have to be even more creative and say, okay, use your professional judgment to rank those variables and what you perceive to be their order of significance. That will then lead you down here. Where the clients have lost in court, I'm saying it's because they haven't been descriptive about what they've done. They said, I looked at many, many alternatives. I always tell people, hey, I've seen a description for over $1 million written on a single piece of paper. Not even 2/3 of a piece of paper. And we did 43 different prototypes in 7 different classes. Here's what was different about each class and why we had to do it. The reviewer came out. He said, oh, I used to do all the same kind of work here too when I was an engineer in industry. And did you use forms? And did you consider thermal rides? Oh, yeah, we did. Here's some pictures. He said, beautiful. 43 prototypes. I estimate each to be 600 to 800 man-hours. $1 million assessed as filed. Very easy, right? You see what he did? Number of alternatives, reasonable amount of time for alternative, yeah. What if I said, I'm really close, I did many prototypes. Anybody, what's many times 500 hours? What if I said I did many, many prototypes? Think that's going to trick them? Well, you get my point. People think, oh, I'll use language like that and I'm going to trick the CRA reviewer. They're not going to think to ask me how many prototypes I actually did because they'll be skilled in the art and say, well, I think a prototype like this is 50 hours. How many did you do? Many, many? That's going to get you a site visit. I'm saying most of this stuff is common sense. There's only really 3 ways to do experiments, I'm going to tell you. You either analyze stuff, maybe an hour per. You say, oh, out of these 20 that I analyzed, 2 look good. I go on the shop floor and I have to kick everyone off the machine and run stuff through and flush it. Well, now each of those maybe takes 20 to 100 hours. Or worse yet, I say, there's no way we can tweak our existing machinery. We've got to start all over and build a complete prototype. And then that's the 3A and B, because I usually don't build a $1 million machine and nail it on the first try. I revise it 10, 15, 20, 30 times. And then those are thousands of hours. So we've proposed that if you provide not only what you did, but the number of alternatives to show I didn't get it on the first try. I looked at 5 alternatives, or 10, or 20, or 50. Ideally, if I looked at 50 or 100, what was different about them? Why did I need that sample? Just very briefly. If that happens, the rest of everything falls in place. How did my results compare to my objectives? And most importantly, did I have a technological advance? I would propose that if you read the tax court's definition, the conclusion at the end of the day is the technological advancement. A conclusion that it can't work because, or it can work because, it doesn't matter if you're successful or not, you have to be trying, or even if you're correct, you have to be attempting to explain a new understanding of those variables and how they work together that wasn't readily apparent at the start. And if you follow that process, guys like Gentel and groups like that, I don't think they would have any problems. So again, I would take that case in a bit of perspective. Okay.